Here we have a geometry problem on two column proof. So here we have some information there. That is AB is congruent to BC. D is the midpoint of AC. Here we have two information about this triangle ABC. That is the side of the triangle AB is congruent to the side of the triangle BC. And also D is the midpoint of the side AC of the triangle. And we have to prove that the line segment BD over here bisects the angle measure ABC. That is the line segment BD over here divides the angle measure ABC over here into two equal parts. That is, we have to prove the interior angle measure over here and the interior angle measure over here must be equal. Okay, so I'm going to give two column proof for this one. Okay, now let me write the required stuff. Here we have two columns. In the first column, I'm going to write the statements, and in the second column, I'm going to write the reasons. Okay, so first what we have to do is we have to consider the given information. We have two pieces of information. The first piece of information is that is the line segment AB is congruent to the line segment BC. So it is given in the question itself. Okay, now the second one is D is the midpoint of the line segment AC. That is also given in the question itself. Since AB and BC are congruent, we can have markings over there. AB and BC are congruent. And since D is the midpoint of the side AC, so the point D will bisect the line segment AC into two equal parts. That is, the length of the line segment AD and the length of the line segment DC must be equal. Okay, so we can write the stuff over here. So AD is the line segment AD is congruent to line segment DC. So the reason for this one is definition of midpoint. Let me write this stuff over here. Definition of midpoint. Okay, now let's consider two triangles over here. There is one is ABD and other triangle is CB. D over here. So, and BD is a common side for both the triangles. So always a side is congruent to itself. Let me write the stuff over here. BD is congruent to BD itself. So this property is called a reflexive property. Let me write the stuff over here. Reflexive property. Actually, reflexive property says an angle measure is congruent to itself, and also a line segment is congruent to itself. That is, the measure of an angle is equal to the measure of the same angle, and also the length of a line segment is equal to the length of the same line segment. This is what is said by reflexive property. So by reflexive property, we can say that the line segment BD is congruent to itself. That is, BD is congruent to BD. Okay, now let me consider two triangles over here. One triangle on the left side, that is ABD. One triangle on the right side, that is CBD. Okay, now let me consider the side AB of the triangle on the left side. So the side AB is congruent to the side CB of the triangle on the right side. And also the side AD in the triangle on the left side is congruent to the side DC of the triangle on the right side. And BD is a common side for both the triangles. Okay, so the three sides of the triangle on the left side are congruent to the three sides of the triangle on the right side. So the two triangles, let me write the vertices in order. Let me take the vertex A in the triangle on the left side. So the corresponding vertex in the triangle on the right side is going to be C. And now let me take the vertex B on the triangle on the left side. The corresponding vertex is also the same B in the triangle on the right side. Now let me take the vertex D in the triangle on the left side. The corresponding vertex in the triangle on the right side is also D. So these two triangles are congruent. How can I say that the two triangles are congruent? By side-side congruence postulate. That is, the three sides of if three sides of one triangle are congruent to three sides of another triangle, then by side-side triangle congruence postulate, the two triangles are congruent. So now we have proved that the triangle ABD on the left side is congruent to the triangle CBD on the right side. Whenever two triangles are congruent, then the corresponding parts of congruent triangles must be equal. Okay, now let me consider the interior angle measure of the triangle ABD on the left side. That is angle measure ABD. Okay, what is the corresponding angle measure in the triangle on the right side? That is CBD. Let me write it over here. CBD. So the interior angle measure over here in the triangle on the left side, the interior angle measure over here in the triangle on the right side are corresponding parts of the two congruent triangles. So since these two are corresponding parts of the two congruent triangles, so the angle measured over here, the angle measured over here must be congruent. So the reason for this one is CP, corresponding parts of congruent triangles are congruent. CP-CTC theorem. Okay, now we have proved this angle measure and this angle measure are equal. Actually, the line segment BD divides the angle ABC into two parts, and both the parts are equal. Since the line segment BD divides the angle ABC into two equal parts, we can say that the line segment BD bisects angle ABC. So we conclude this one by the definition of angle bisector. Let me write the stuff over here. So BD bisects, let me write it over here, angle ABC. The reason for this one is a definition of angle bisector. Let me write the stuff over here. Definition of angle bisector. Using the given two information, now we have proved that the line segment BD bisects the angle ABC.